Hey everyone, and welcome to another episode of Mrs. Ross Does Math. Today's lesson is for Math 8. This happens to be the final lesson of this unit and the final lesson of this textbook. So our focus today is lesson 20, the distance formula. Now the distance formula can be a little bit tricky, so we're going to go over several examples today. And the biggest piece with the distance formula is making sure that you are identifying your information correctly. That can be where you have your largest hiccup in accurately getting your answers. So let's get this going. So to begin with, once again, this is lesson 20, the distance formula. I'm going to zoom in and we are going to refocus. And there we go. So our essential question for this lesson is, how can I find the distance between 2 points on a coordinate plane using the distance formula? As we talked about in lesson 19, a coordinate plane is a graph. So for this particular lesson, we are going to be using 2 different points or 2 different coordinates or locations on a graph. And we will be using that information in a specific formula to determine the distance diagonally from one point to another. Now, the distance formula is going to be your best friend for this unit, so I would highly recommend on your lesson and when we do our examples, since I have the examples on a separate page, that you go through and you rewrite this formula. D for distance is equals to the square root of x2 minus x1 in parentheses squared plus y2 minus y1 parentheses squared. Now this x2, x1, y2, y1, those are your coordinates. So x1 and y1 are going to be part of the first set of coordinates you see, because remember we read left to right, so our coordinates go left to right. So the one that we see first going left to right is our x1, y1. And then the one that we see second is the x2, y2. So the distance formula uses D for distance when 2 points the distance formula uses D for the distance between 2 points instead of C like the Pythagorean Theorem. So we're still finding the diagonal, which is the C, the hypotenuse, but here we're using D because we're specifically looking for the distance between those 2 points. When we talk about some keys to success in using the distance formula, the first thing that we want to make sure of is that the horizontal leg of the triangle is always the difference between our x coordinates. So A, if we're connecting this to Pythagorean Theorem, A is going to be x2 minus x1, or our 2 x coordinates, the horizontal coordinates. Again, if we're connecting this to Pythagorean Theorem, the vertical leg of the triangle is always the difference between the y coordinates. So B would be y2 minus y1. And looking at this on a graph, just so this way you guys have a visual idea, here I have my graph. Because this is the first point I see, this is x1, y1. Because this is the second point I see up here, this is x2, y2. My A is the difference between my x's. My B is the difference between my y's. The C is our diagonal, our hypotenuse, our distance. So keeping this in mind, let's go ahead and get going on our examples. The first example I have for you is this here. It says use the distance formula to calculate the length of each segment. So our segment that we're trying to find is the segment here in green. Now it's going to really help us in creating this equation. 1, if we rewrite the equation, and 2, if we identify the points as x1, y1 and x2, y2. So I'm first going to start off by writing down our equation. So D for distance formula is equals to the square root of x2 minus x1 squared plus, in parentheses, y2 minus y1 squared. And I'm continuing that all the way down. Now, what I'm going to do is I'm going to identify what is my x1, y1, and what is my x2, y2. My first point that I have is 1, 1. This is my x1, this is my y1. The second point I have is 4, 5. So this is my x2, my y2. What we'll do now is we will go ahead and plug these numbers into our formula. So I'm going to go d is equals, and I'm going to do a really long square root, x2, which is 4, minus x1, which is 1. I'm going to put that in parentheses, and I'm going to square it. Now I'm going to use a plus sign, and I'm going to go y2, which is 5, minus y1, which is 1. And that's going to be squared. Now, I'm going to rewrite this once again. D equals the square root. I'm going to now find out what the value of 4 minus 1 is, because I need to figure out what's inside those groupings of parentheses first, and that's 3. Now, I'm going to keep this in a parentheses, and you'll see why later on. And next, 5 minus 1 is 4. So I'm going to do 4 in parentheses with the squared as well. Now, I need to find out what the value of 3 squared is. So D, with my square root once again, 3 squared is 9. Now I can remove those parentheses, and 4 squared is 16. So I'm going to find out what the value of 9 plus 16 is. So D is equals to the square root of 25, because 9 plus 16 is 25. Now, what happens to be the square root of 25? And that's 5. So our answer is D is equals to 5. And that happens to be our final answer. So, keeping this in mind, we have another problem, but this one doesn't have a graph. It simply identifies the coordinates. So that's actually going to make it a little bit easier for us moving forward. So here we go. So example number 2, it says find the distance between 7, 9 and 4, 6, round to the nearest tenth. So this one is not going to have a clean whole number. We're going to need to go ahead and make sure that we're rounding to the nearest tenth, which is 1 digit behind our decimal. So first of all, let's start off once again by identifying what is our x1, y1, what's our x2, y2, and write the equation. So my equation, once again, is D is equals to the square root, and I've got a long square root, of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. I have 7 and 9. Those are the first set of coordinates that we are given, so that happens to be our x1, y1. Next, we have 4, 6. That's our second set of coordinates that we're given, so we're going to use that second. So I'm going to have 4, 6, and I'm going to write that as x2, y2. Now, I'm going to substitute in those numbers. So I have D is equals to the square root of x2, which is 4, minus 7, which is x1, in parentheses squared, plus, in parentheses, 6 minus 9, because 6 is my y2, 9 is my y1. And that's squared. Now, 4 minus 7 is negative 3. I'm going to keep that parentheses with that. I'm also going to keep the parentheses when I go 6 minus 9, which is also negative 3. So I get D equals in the square root of negative 3 in parentheses squared plus negative 3 parentheses squared. Now, negative 3 squared, that is negative 3 times negative 3. So I'm going to get 9. And negative 3 times negative 3 is 9. So I have D is equals the square root of 9 plus 9. Well, 9 plus 9 is 18, so I have d is equals to the square root of 18. And then the square root of 18 comes to be approximately 4.24. Now, we want to round this to the nearest tenth, which means we want to focus on this 2. Is that 2 going to move up and become a 3, or will it stay as a 2? In this particular problem, because the 4 next to it is less than 5, we're going to go ahead and keep it as 2. So our final answer is d is equals to 4.2. Now, if you have any questions at all, please go back, rewatch this lesson, send me a message, leave me a comment. I will also link a couple of additional videos that I feel might also be helpful. But please, please, please reach out with any questions you have. I am here to help any way I possibly can. All right, now moving forward into our assignment. Your assignment is Lesson 20 worksheet, the distance formula. It's going to be very, very similar to some of the problems that you had in the examples. For this particular assignment, please make sure that you write your name, today's date, and the class period on this. For me, my name, Mrs. Ross. Today's date. Today happens to be 5/5. That's my recording date. And this is for period 1, which is when Math 8 occurs. Next, it says, use the distance formula to calculate the length of each segment, round to the nearest tenth. So we're going to need to make sure that once again, we round to the nearest tenth. Now before we get started, I'm going to write our equation at the top. D is equals to the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Okay? We always want to make sure that we're writing down those formulas. Next, I'm going to go ahead and do number 2 to begin with and let you guys practice number 1 on your own. Okay? So here, for number 2, let's start off by identifying what is our x1, y1 and what is our x2, y2. Here, I have x1, y1 in -4, -1 because it's the first coordinate point we see. And over here, I have x2, y2 on the 3, 1. Next, we're going to need to plug this information into our formula. So we have d is equals to the square root, and again, that long square root, x2, which is 3, minus x1, which is -4. So I have minus a minus. I'll transform that later. That's going to be squared. Plus my y2, which is 1, minus y1, which is -1. And again, we'll have to do some transforming later. Here, a minus and a minus create a positive, so I actually have 3 plus 4. So I'm going to have d is equals to the square root of 3 plus 4, which is 7, squared, plus 1, and here, same thing, we're going to create a plus sign. 1 plus 1 squared, which is 2 squared. Now, I'm going to find out what the value of 7 squared is. 7 squared is not 7 times 2, but 7 times 7, which happens to give us 49. So d is equals to the square root of 49 plus 2 squared, which is 2 times 2, which gives us 4. So we have 49 plus 4. That's going to give us d is equals to the square root of 53. And I'm good, but I'm not that good. The square root of 53 is 7.28. So we get d is equals 7.28. Now, if we paid attention at the top in the directions, it says round to the nearest tenth. So we're going to look at rounding the 2. Is the 2 going to stay the same, or will it change and become a 3? In this case, because of the 8, it's going to round up and become a 3. So our final answer is 7.3, and that's it. Next, we're going to go ahead and begin with number 4. Now numbers 3, 4, 5, 6, 7, and 8 are all very similar. Okay, so on these, if you have any questions at all, please refer back to example number 2, which is the first example that we did. Now, in this, I am going to make number 5 and number 8 some extra credit because they both have a decimal. Now, I'm not saying that that's going to make it a little bit more difficult. Oh, sorry, not number 5, just number 8. Number 8 will be the one that's extra credit. Now, it's not going to be more difficult, but you're really just going to need to make sure that you're paying attention to the numbers that you're plugging in into the calculator, as well as your rounding, because you're going to be getting some really funky decimals as you're solving this. Okay, so number 8, only number 8 will be extra credit. Okay, so to start off, I'm going to go ahead and do number 4. Okay, so number 4. Here we go. Number 4 says, using the distance formula, find the distance between each pair of points. If necessary, round to the nearest tenth. So once again, I'm going to write down that equation, and that equation is d is equals to the very long square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Okay, so let's get it started. Number 4, this is our x1, that's our y1, this is our x2, this is our y2. Okay, first set of coordinates we see, second set of coordinates we see. So let's plug this in. I'm going to have d is equals to the square root, trying not to infringe upon the 5. If you need to do this work on a separate sheet of paper, that's totally fine. Please just make sure that your name goes on it. I want to be able to give credit where credit is due. So here, I'm going to go negative 1 minus 3 in parentheses. Whoop. Brain fart. Negative 1 minus 3 in parentheses squared plus 10 minus 9 in parentheses squared. Okay, because that's y2 minus y1. Next, negative 1 minus 3, that's negative 4. So I'm going to get d is equals to the square root of negative 4 squared plus 10 minus 9, that's 1 squared. Negative 4 squared is negative 4 times negative 4, so that gives us 16. So I have d is equals to the square root of 16. 1 squared is 1 times 1, which is 1. Next, d is equals to the square root of 16 plus 1, which happens to give us 17. And lastly, the square root of 17 is 2.03. Nope, that's not right. 4.12. Sorry about that. So d is equals to 4.12. Now, once again, it says round to the nearest tenth. So here, we're going to take a look at the 1. Is the 1 going to round up, or will it stay the same? In this particular case, if you said stay the same, you are correct. Our final answer is 4.1. Now, once again, if you have any questions at all, please leave me a comment, send me a message. I am here to help any way I can. Thank you so very much for watching. This has been Mrs. Ross Does Math.